Welcome to the Corrosion channel. My name is Ehtesham Zade. I'm a researcher in the field of corrosion and protection of materials. An introduction to this channel is available on video number E28. Chapter 9, Section 10. Risk-based inspection. In this video, using RBI for risk management. The reference: Elements of a risk-based inspection program, API Recommended Practice 580. Using RBI for risk management includes 1. Identification of risk drivers. 2. Inspection optimization. Inspection optimization includes risk management through inspection, using RBI to establish plans and priorities. Other risk management examples. 1. Identification of risk drivers. The mechanical integrity and functional performance of equipment depend on the suitability of the equipment to operate safely and reliably under the normal and abnormal or upset operating conditions to which the equipment is exposed. In performing an RBI assessment, the susceptibility of equipment to damage by one or more mechanisms, for example, corrosion, fatigue, and cracking, is established. The susceptibility of each equipment item should be defined for the current and the projected operating conditions, which should include such factors as A. Normal operation. B. Upset conditions. C. Normal startup and shutdown. D. Idle or out of service time. And E. Emergency shutdown and subsequent startup. Process variables that should be considered for each operating condition include, but are not limited to: 1. Process fluid, contaminants, and aggressive constituents. 2. Pressure, including cyclic and transient conditions. 3. Temperatures, including cyclic and transient conditions. 4. Flow rates. And 5. Desired unit run length between scheduled shutdowns or turnarounds. The suitability and current condition of the equipment within the established operating conditions limits will determine the POF of the equipment from one or more damage mechanisms. This POF, when coupled with the associated COF, will determine the operating risk associated with the equipment item and therefore the need for risk management. An appropriate risk management program should be developed to address the risk drivers. Since risk is most often dynamic, that it changes with time, the RBI process that is developed or selected for application should have the ability to be updated, including changes in the inspection plan when changes occur or new information is discovered. Such changes include: A. New data from inspection activities, that is, changes in rates of deterioration are noted in external, internal, or on-stream inspection. B. Changes in operation, operating variables, or operation outside of process limits. C. Changes in the process fluids. D. Changes in process equipment, including additions. And E. Equipment leaks or failures. Change information shall be communicated so that modifications in the risk-based management plan can be made. 2. Inspection optimization. When the risk associated with individual equipment items is determined and the relative effectiveness of different inspection techniques and process monitoring in reducing risk is estimated or quantified, adequate information is available for creating a risk-based management plan. However, an effective RBI program implementation will also include strategies for optimizing the overall inspection program. This figure presents stylized curves showing the reduction in risk that can be expected when the degree and frequency of inspection are increased. The upper curve in the figure represents a typical inspection program. Management of risk using RBI. Level of inspection activity. Assessed risk. Risk with typical inspection programs. Risk using RBI and an optimized inspection program. Residual risk not affected by RBI. Where there is no inspection, there may be a higher level of risk, as indicated on the y-axis in the figure. With an initial investment in inspection activities, risk generally is significantly reduced. However, a point is reached where additional inspection activity begins to show a diminishing return and eventually may produce very little additional risk reduction. If excessive inspection is applied, the level of risk may even go up. This is because invasive inspections in certain cases may cause additional deterioration. For example, moisture ingress in equipment with polythionic acid, inspection damage to protective coatings or glass-lined vessels. This situation is represented by the dotted line at the end of the upper curve. A complete RBI program provides a consistent methodology for assessing the combination of methods and frequencies of inspection. Each available inspection method can be analyzed and its relative effectiveness in reducing the POF can be estimated. With this information and the cost of each procedure, an optimization program can be developed. An optimization methodology is developed by assessing the risk associated with each item of equipment and determining the most appropriate inspection techniques for that piece of equipment. A conceptual result of this methodology is illustrated by the lower curve in the figure. The lower curve indicates that with the application of an effective RBI program, lower risks can be achieved with the same level of inspection activity. This is because through RBI, inspection activities are focused on higher risk items and away from lower risk items. As shown in the figure, risk cannot be reduced to zero solely by inspection efforts. The term residual risk describes the risk that remains after all effective risk reduction and mitigation activities from RBI have been performed and or implemented. The residual risk factors for loss of containment include, but are not limited to, the following. A. Human error. B. Natural disasters. C. External events, for example collisions or falling objects. D. Secondary effects from nearby units. E. Consequential effects from adjacent equipment in the same unit. F. Deliberate acts, for example sabotage. G. Fundamental limitations of inspection methods. H. Design errors. And I. Unknown or unanticipated damage mechanisms. Many of these factors are strongly influenced by the process safety management (PSM) system in place at the facility. Challenge number 48. Thank you for your attention. If you'd like to challenge yourself, please answer these questions in the comments below. 1. Which changes should be considered during RBI process updating? 2. As shown in the figure of this video, slide number 843, the lower curve indicates that with the application of an effective RBI program, lower risks can be achieved with the same level of inspection activity. Why? 3. Describe at least 5 residual risk factors for loss of containment.